Welcome everyone. My name is Maria Husmann, and I recently finished my PhD here at ETH in Zurich. I am now a part-time lecturer with the Lucerne University of Sciences and Arts. And in this talk, I'm going to give you roughly a 20-minute introduction to the topic of my PhD, so what I spent roughly the last 5 years researching. And that is how we can develop user interfaces that are distributed across multiple devices. So we have more and more devices. We have smartphones, tablets, laptops, smartwatches, and even TVs that are connected to the internet. However, most applications have been built to be used by a single device at a time. But we have studies that show that people sometimes already try to use multiple devices in parallel, but that's not very well supported by most applications. So sure, we have some basic synchronization like Dropbox or Google Drive. And we have accounts that we can share across devices that synchronizes some of the data. However, the interaction is still quite cumbersome. You have to copy files into the right folder and access them again. And I don't know about you, but I still email things to myself sometimes just so I can get them from one device to the next. Does anyone else here do that? Okay, yeah, that's almost more than half at least. So why would I even use multiple devices in parallel? I can think of several reasons. So one advantage is that we can have more screen real estate in, for example, in mobile situations. And I took this photo of someone who is shopping for wine on a train, and they're using both their phone and a tablet at the same time to have essentially a larger screen. Then another benefit of using multiple devices is that we can potentially get a richer set of input and output modalities. So here you can see a phone and a laptop being used at the same time, and the phone is more mobile than the laptop. It has a camera and has touch input, whereas the laptop has a keyboard and a larger screen. So if you're working with a document on paper, for example, you might want to scan it with your phone, but then continue working with the laptop because it has a larger screen and the keyboard. And also in collaborative scenarios, it could be interesting if you have user interfaces or applications that can distribute across multiple devices. So for example, that each user can work with their own personal device, or they could also work with shared devices. So here we have a mix of personal devices like the phone and maybe the laptop, and shared devices like a tabletop. And we can even try to identify the user based on the device that they are using. So to give you a better idea of what I'm talking about, I want to show you 3 applications that I've built either myself or together with some students that I supervised. And they're all in prototype state. So the first one is a simple webcam viewer. It shows webcams that are distributed around Switzerland. So it has been built to show images on large screens that you could, for example, have in the lobby of a hotel. And then the user can control the content that is shown on the large screen by pairing their phone to the screen. And then with the phone, they could, for example, select the camera location or change the angle of the camera. So here's a screencast of the application. To pair the emulated phone in this case, I'm just copying the URL, but I could also scan the code. Now I can control the angle, and I can also go back and forward in time. Then when I flip the phone, I can choose different locations to show. So the next application was built for mountain bikers. It's a trip planner. So Switzerland is a really great country for mountain bikers, and there are repositories of bike routes that help you plan your next trip. And they usually have a lot of information, so they have a summary of the ride that you could do, and elevation profiles. Usually there's a map and a GPS track that you can download. There are images, maybe even comments that tell you, don't do this, I did this and it was horrible, or there's a bridge that is broken, so you shouldn't do it now. So all this information is nice to have, and that works quite well when you have a larger device like a laptop, for example. But on the phones, these applications aren't very nice to use. So either you have to go back and forth a lot, or they just reduce the information that they present. So we thought, what if we take this information and we distribute it across multiple devices? Our idea was that when you're out with your friends or maybe with your partner for a bike weekend and you're on the train, you could just take out all your phones and combine them into one larger screen. But we didn't want to limit ourselves to just supporting phones. We wanted an application that can adapt to any kind of device. So for example, if you go to a hotel and it has a TV, it would be nice if you could integrate the TV screen as well. And just last week I found this in a mountain biking magazine, so hotels are now advertising themselves with having huge screens where you can plan your bike trip. So it would be nice if such a thing could be integrated as well. So the application that we built for this scenario was built up from a set of components. So for example, we have a map component, we have a summary component, we have the elevation chart, and so on. And some components are smaller, like the summary, while some components like the map are better displayed on larger displays. So we calculate or we analyze the components we have, and we look at the devices that are currently using the application. Then we distribute the components across the available space. I also have a screencast to show you here. So on the left, I simulate 2 phones. And when a route is selected on the device on top, it updates the map on the device at the bottom. And then when we add a third device, a larger one, the elements on the interface redistribute. So the map is now moved to the larger device, and we have more room to display additional components like the elevation chart at the bottom, while everything is still synchronized, so they all show information for the same bike route. Then the third application essentially targets people like some of you here, or most of you probably. It's an IDE that distributes across multiple devices. So maybe this looks familiar to you. Most developers that I know like to use multi-screen setups to have 2 or 3 large screens. But there are situations where you probably don't have access to that. For example, if you're working on a train, maybe you're traveling and working from an airport, you're at the cafe, or maybe you're even at the client's location and you just have your laptop, but you don't have your usual setup. So for this kind of scenario, we built an IDE that can integrate the user's mobile devices. So for example, you probably still have your phone with you, so you could add that to the IDE. And what it does is the IDE can display additional information on these mobile devices. For example, if you're writing a web application, you can write the code on your laptop, because probably with the keyboard and the typing, it's a lot more convenient than to try to code on the phone. But then you can have a look at the output, at the actual application on the phone. And as soon as you save on the laptop, it will update the phone. But you could also display the console logs on the phone. So now the application that is being developed is actually run on the laptop, but you see what the console outputs are on the mobile phone. And then if you select one of the lines in the output, it will open the editor again on the laptop. So we again decided to always open the editor on the laptop, because that's where you type, and so it will be aware of the capabilities of the devices. You can also search, so you can trigger the search from the laptop, you enter a keyword there, and then the results will be listed on the mobile phone. So you can have the mobile phone visible to you while you maybe jump between the results. So you click on a result, it opens the editor in the right place on the laptop, you have a look, maybe it wasn't what you was looking for, you go back to the phone, select the next result, and it opens again on the editor. So these were the 3 applications that I wanted to show you. And now I want to talk about challenges, because when building these, you'll probably run into challenges, because at least we had some challenges building them. So one thing we have to take care of is synchronizing state across the devices. So if you click something on the phone, this may have an impact on the tablet, and you somehow have to communicate this across the devices. We also have to think about how we distribute UI elements across the devices that are there. For example, here we distribute them based on the space that is available on the devices. That's what we did in the biking applications. You look at the components you have, you look at the devices you have, and that's how you decide what should go where. But you could also distribute the UI based on kind of the device types or capabilities. For example, you could say, I put all the same components on the phone. For example, with the webcam application, you always want the phone to be the controller, and the larger screen would be a viewer application. But what if we take away a device in a situation? Should the user interface adapt? Or does it just not work if you come with the wrong kind of combination of devices? And where do you even determine that? So is there a central server that decides what should go where, or can you calculate this on the client? And then you also have to associate devices somehow. So you somehow have to tell the system that we have maybe a group of devices over here that works together, and then the two devices over there form a group. So there should only be the communication among the groups and not between them. So it was the goal of my PhD work to investigate how we can make developers' lives easier when building such applications. And I have explored some solutions to these problems. And one thing that can make their lives easier is if we provide building blocks, if we provide libraries or frameworks that abstract away some lower level details. And I built a prototype of such a library myself. It's on GitHub. You can see the link there if you want to have a look. It's web-based, and it integrates with the Polymer framework. So maybe before I go into the details of the library, I want to quickly tell you why I chose web technology. So one thing, just looking at myself, so I have a Windows laptop, I use an Android phone, I also have an iPad. So that's already 3 different operating systems. So we wanted to have something that works cross-platform out of the box, that you just develop once and then run everywhere. And web technologies satisfy this requirement, or at least in most cases. And on top of that, they have the benefit that they don't require installation. So if you have an app, you don't have to go install it on all devices. And they've become increasingly powerful. So we now have access to the camera, to sensors, and we have new protocols like WebSockets or WebRTC. The main drawback I see for this case is that they don't support wearables very well, so or smartwatches. Well, yeah, now let me move on to some of these problems and what we try to do to address them. So if you build web applications nowadays, you probably use some model view, whatever framework, like React or Angular, Vue, or Polymer. And they usually offer some mechanism for state management, and you can hook into that mechanism to synchronize the state across the devices. So if you have an interaction with a view on a device, this triggers an update to the model. You can then take this update, send it across the network, and trigger an update to the model on the next device, and it will there then trigger an update to the device, to the view. You could use a real-time database like Firebase to implement something like that. We decided to go with WebRTC, which is a somewhat newer protocol for direct communication between devices. So the main advantage of this is it significantly lowers latency, especially when you have the devices that are communicating in the same room and the server is somewhere remote. And this is exactly the scenario that we think about when we think about cross-device applications. So we have devices that are in the same room. And most frameworks offer some sort of data binding mechanism. And we use this mechanism to let developers specify what should be synchronized. So with our library, they can bind to this synchronized component and then use that again in other places. So what you see here is Polymer code, and it's actually from the webcam application. So there's one part where you can select the camera that should be shown, and it binds to this synced object. And then we do the same with the image. And now it means that the selected camera will be synchronized across any devices. So the two components, the selection part and the image part, no longer need to be on the same device, and the system will take care of the synchronization for you. For the UI distribution, our library propagates information such as the screen size to all paired devices. It's then up to the developer to decide what they want to do with this information. They can, for example, show or hide certain UI elements. They can also attach roles to devices. So we have on the left side we have the phone, which is a small device and which has been added the controller role. And then we have the larger screen, which has been assigned the viewer role. And this information is again propagated among all connected devices, and it can be used to decide what should be shown or not. And then for deciding, once you have this information, you can hook into mechanisms again that are provided by the framework. So most frameworks offer some sort of conditional rendering for their UI part. So you could, for example, say that the video controller element should only be shown if we have this role that is present. So only if you have the controller role, or a video player element should only be shown if there is a player role present. And then the UI frameworks actually take care of creating the DOM nodes, depending on if the conditions are satisfied. So what I just showed you is quite powerful. You as a developer can essentially implement anything, but it also means you have to decide a lot. You have to look at the device sizes, you have to look at the device types, you have to decide what UI elements should be shown where. And we also have created a couple of layout templates for what we think are more common scenarios. So in that case, you could just use a template and it would implement that scenario. For example, here we have a remote control pattern where we have controller devices, typically phones, and viewer devices like larger screens. And you could say, this is the pattern that my application uses. And as a developer, this is the code you would need to write. So you have to wrap it in this custom component. And then you have to annotate any content that should go to the controller devices with a controller class. And similarly, you need a viewer class for anything that should go to the viewer devices. Then for the pairing, we have implemented an approach where each device modifies its URL and adds an ID at the end. And then when another device accesses that URL, the two devices will be paired. And we call the first device the connectee device, and the device that initiates the connection, the connector device. This information that is in the URL can also be encoded into a QR code, so it can be scanned, or it could also be transmitted using NFC. So using the library that I quickly introduced and these concepts, this application was built in less than 300 lines of code, and that's in the client and server combined. And here's the most relevant code for the application. So we have the state synchronization at the top, then we have the pairing based on the URLs, we have this layout template with the content for the phones, the controllers, which is not shown here, and then the content for the viewer, the big screen. So the viewer essentially just shows the QR code for the pairing and the image itself. And the rest of the 300 lines of code was mainly import statements, CSS, and then also some JavaScript to handle user interaction. So having seen these examples, I hope that from now on you can see the set of devices that a user owns as a whole, and that this maybe opens up ideas of applications in your own domain. And if you do build something, please let me know. I'm very interested to see more examples. So if you'd like to know more, you could read my PhD thesis if you want, but maybe it's easier if you just talk to me in the break. Thank you.